Today we're going to solve match to binary trees. So this question is a question where this question is to match to binary trees, basically, right? Let me not say what which match to binary trees. Yeah, but you get a binary tree, you get another binary tree, and we're supposed to match it in a way where the nodes coincide, you add them, and where it doesn't coincide, you basically take it like you're adding zero. Yeah, so for example, now 1 plus 2 is 3, 3 plus 1 is 4, 2 plus 3 is 5. Then yeah, we have 5 plus nothing is 5, 0 plus 4 is, so basically it's like you're taking the two trees and you're merging them, you're putting them on top of each other. Where they coincide, you add; where they don't, you just extend. You get. So yeah, so it's the I think the question is explanatory, right? So I'm supposed to get this. Let me just let's see if we can figure out how to solve it from drawing. Okay, so 1 3 2 5 1 1 3 2 5. What this thing looks feels harder to draw. I'm going to need to go and set it. Then 2 1 3 4 7 2 1 3 4 7. I have 2 1 3 2 1 3 4 7. Yeah, 4 7. So we extend it like this. Okay, so how do we solve this? How do we solve it? We know the solution, right? We're going to be putting them together. So it's going to be 3 when we add 1 plus 2, 3. Then 3 plus 1, 4. Then this one will give me 5. Then this one will give me 5. Then 4. Then 7. Yeah, but how do we solve it with code? How do you solve it with code? You can solve it by probably looping through this, and at each node, right, we add the corresponding node. I think that's something. At each node we have this corresponding node. So we go with 1, then we add 1 plus 2, 3, then we update this particular node. Then we branch to the left. When we branch to the left 3, we also branch to the left of this one. Yeah, we can solve it like that, or better still, we can use recursion to solve it in a way that we're going to be recursing together. So when we're recursing together we'll take the node of each of them. Node 1 and node 2, and then we'll do when we get to the node, we'll do if the value of both of them exits, obviously we'll do node 1 dot value, the value of it, plus node 2 dot value. Now instead of updating, we can create a new node. We'll create a new node. So it's going to be a new node. Then at the end of the day, we'll be returning that node. But before we return that node, we would attach to the left of that node, and then we'll attach to the right of that node. So when we attach to the left of that node, we want to attach whatever the node would give me. Whatever I want to attach, but we want to attach the recurse value of, now since we're going to the left, since we're attaching to the left, we want to attach the left of node 1 and attach the left of node 2. So basically this is what is going to happen. For the first recursion, we'll be going from this node, we'll be in this node, and this node. It will create a new node and assign the value 3. Then it will branch out to the left. It will return 3 at the end of the day. It will branch out to the left. When it branches out to the left, it will branch out to the left by doing the same thing but passing the left value. That's node left and node right. So it will pass 3 and 1. 3 and 1 will do the same thing by creating a new node, adding them together, which is 4, and it's going to branch out to the left again, which is going to be 5 and not 10. Now we could do something in which we'll be adding 5 plus 0, which if it does not exist, we take it as 0, but it's going to take time. So instead of that, anytime we get to a situation where only one node exists, instead of us to turn the node that does not exist, that is none, to 0, what we could do is we could just attach the rest of the node. So for example, now 3 and 1, since only 5, since only the left of, since only node 1 exists and node 2 does not exist, and node 2 does not exist, we'll just attach only till left to the rest of node 1. So basically, even before we recurse, we want to check. Anytime we recurse, we want to make sure that node left and node right exist. If node left exists and node right does not exist, we just want to attach everything to node left, and vice versa. But if both of them exist, right, then we want to then recurse. So same thing will happen to the right too. We will recurse at the right too, and at the end of the day we'll be returning t. Yeah, I'm going to explain more when I'm solving it. This is like a very, very, very scattered wolf. I hope you guys get the point, yeah. Yeah, so I'm going to increase this. Let me just increase this so that it's more visible. Yeah, so we're going to be doing recursion, and the first thing we'll do is we're going to take a function, and our function is going to take in two nodes, node 1 and node 2. Now we're going to do a base state. So if node 1 is none and node 2 is none, node 1 is none and node 2 is none, none is none and node 2 is none, we can just return, which we can actually do our base statement here actually, and just do if node 1 is none and node 2 is, if node 1 is none and node 2 is not none, if node 1 is none and node 2 is not none, only return node 2. If node 2 is none and node 1 is none, then return node 1. But if both of them are none, return this thing. Should we do that? Yeah, let's try that. So if node 1 is none and node 2 is none, just return none. If node 1 is none, if node 1 is none and if node 1 is none and node 2 is not, and node 2 is not none, so for this one, since node 2 is not none, I just want to return node 2. And then finally for the next one, so that's if node 1 is not none and node 2 is none, in that case I just want to return the one that is not none, node 1. So this will be my base cases. Otherwise I want to create a new, let's call it T, a new tree node. And when I create a new tree node, I want to pass the value of, since both of them are not null, they both have value. I want to pass the value of node 1 and node 2. And then I want to attach to my left of the T, I want to attach a recurse of node 1 dot left and node 2 dot left. And I want to also do it for the right, so I'm going to go to the left, I'm going to go to the right, you know, the way it was meant to be. The way God dictated it to be. Yeah, don't mind me. And I'm going to go to the right, and at the end of the day I'm going to return T. You know what, I think I feel more comfortable just calling it, no, let's call it T. I want to say I feel more comfortable just calling it node, but I guess T is fine. And then we're going to call the function recurse, and we're going to pass in the value of root 1 and root 2. Yeah, so you know what, let me test it first before before I explain again. Okay, it did not pass for some reason. Expected. Okay. Okay, sorry, I'm not returning. So I want to return the value. Okay, it passes. Yeah. It passes. So let's submit now. Oh, cool. It works. Okay, so since it works, we can explain our solution now. Yeah, so what happens is it gets the value, right? It gets the root 1 and root 2, and inside it adds root 1 and root 2. So let's explain it together with the diagram. It gets root 1 and root 2. It checks if both of them are none. If both of them are none, you return none. If only one exists, you don't need to add again, just return. So for example, if only one exists, it's only if for example 3 and 1, if we're going to the right, since only 4 exist, we don't need to add again, just attach this node and every other thing that would be there to the node that we're building. Same thing too if you're going to the left. Now if both of them now exist, what do you want to do? You want to take the value of both of them, add it, and create a node, then attach to the recurse value, attach to going to the left and doing the same thing, then attach to going to the right and doing the same thing. Yeah, well, I hope you understand this. And that's today's Leetcode problem. Thank you. Have a nice day.